Hello students, in previous lecture we have seen sample spaces. In that sample spaces we have seen finite sample spaces and infinite sample spaces. So what is meant by finite sample spaces? Now if sample space contains finite number of elements, then we say that it is finite sample space. And if sample space contain infinite number of sample spaces or sample points, then it is infinite sample space. Now in that infinite sample space there exist again two types, which is countably infinite sample space and uncountably infinite sample space. So what is meant by countably infinite sample space? Now if there exists sample space which is there exists one onto map with natural number, means there exists set with which is isomorphic to natural number, then this is the countably infinite sample space. And if sample space which is not countably infinite, then which is the countably infinite sample space. Now let's see the examples. Write down the sample spaces of the following experiments. Write down the sample spaces of following experiment. So let's see first. Answer to an objective question. Which has four multiple choices. Four multiple choices A, B, C, D. Student ticks a single answer. So to find out sample spaces of the experiment. So what are the sample points here? So answer to an objective question which has four multiple choices A, B, C, D, means sample space will have only four options A, B, C and D, means student can tick any one, either A, either B, either C or either D. So sample space contains only 4 points, which is A, B and C, D. A, B, C and D. So second question, a coin is tossed till a head occurs. A coin is tossed till a head occurs. So what are the sample spaces here? So I will take sample space. Yes. So if I toss coins until head occurs, so first sample space, if I toss one coin, if directly head occurs, then we will get H. Now next I will toss two coins. So first occurs tail, and then second time it occurs head. Then I will stop here. Now for next I will take three coins. If for first coins it occurs tail and third times it occurs head. So I will stop here again. Now for next I will write 3 times T and H, because here 3 times occurs tails and 4 times occurs head, and continuously in this way. So T, H and so on. So this is the sample space which is isomorphic to natural number there, because here 1 point, here 2 points, here 3 points, 4, 5 and so on. So this set is nothing but isomorphic to set of natural number, means what, this is countably infinite sample space also. So this is second sample space. Third one, 10 seeds are planted. 10 seeds are planted and total number of seeds germinated, are recorded after a week. After a week. So what are the possible sample spaces? So 10 seeds are planted and total number of seeds germinated are recorded after week. So what are the sample spaces are there? So if after week I have observed that if there is no seed germinated, then a possibility will be 0. If from 10 seeds, if there is exist only one seed which will be generated, then one possibility. If there is 2 seeds germinated, then 2 possibility. Now next 3 seeds germinated, then 3. So 3, 4, 5, 6, 7, 8, 9, and total there are 10 seeds. So there are 0, 1, 2 up to so on 10, means total 11 sample spaces. Because if 0 means what? There is no seed germinated. 1 means what? There exists only one seed which is germinated, and up to so on 10. So these are only possible sample spaces in that set. Now next example, a 2-digit number is formed. A 2-digit number is formed. 2-digit number is formed from the digits. So digits are 4, 5, 6. Using each digits 1. Using each digit only once. So what are the sample spaces? So this is second example. So solution of third one. So this is fourth example. So solution of fourth example. So total there are 4, 5, 6. So total 3 letters, and to form 2-digit number which is using each digit only once. So what are the sample spaces are there? So I will write 4, 5. Next 4, 5, 6. 4, 5, 6. Next I will replace in or interchange this. So we will get here 5, 4. Next 6, 5. Next I will write 4, 6, 46, and next I will replace it as 64. So 1, 2, 3, 4, 5, 6. So total there are 6 elements or 6 sample spaces from the numbers 4, 5, 6 which are used only once. This number can be used only once. So total there are 6 sample spaces. Right. Now next example, fifth one. A die is rolled until 4 appears. A die is rolled until 4 appears. So let's see the solution. So if I roll die, so die, we know that die has how many sides? So it has total 6 sides, right? So if I roll die, then it appears 4. So let's see the sample space. Now I will take A is 4 appears, and I will take D, 4 does not appear. Then what is sample space? So sample space will be, so suppose I will roll first times, then I get directly A, means what? Directly 4 appears. Now if I again roll 2 times, then we will get first D means what? Which is elements other than 4, and second time I get 4 means what? A. Now again next time I will roll die 3 times. So first time it gets elements other than 4, second time also get elements other than 4, and third time I get 4 means what? A. Now next if I roll die 4 times. So first time I get elements other than 4, next second time again I get elements other than 4, third time again I get elements other than 4, and fourth time again I get elements 4. So in this way, this is the sequence which I get the sample space until 4 appears on front. Let's see 6th example. Two dice are rolled. Two dice are rolled simultaneously, and the number on uppermost faces are noted, and the number on uppermost faces are noted. Then what are the sample spaces are there? So total we have 2 dice are rolled. Then the sample space has how many sample spaces are there? So we have dice has total 6 sides. So total there 6 into 6 means what? Total there are 36 sample spaces. So what are the sample spaces? So 1 1, 1 2, 1 3, 1 4, 1 5 and 1 6, right? Next 2 1 up to so on 2 6, next 3 1 up to so on 3 6, next 4 1 up to so on 4 6, next 5 1 up to so on 5 6, and last 6 1 up to so on 6 6. So total there are 36 sample spaces in that case. So if I roll 2 dice, then we will get 36 sample spaces. Now we will take next point, which is distinguish between discrete sample space and continuous sample space. So let's see the differentiation between these two sample spaces. So let's see distinguish between a discrete sample space and continuous sample space. Now discrete sample space consists of isolated values, whereas continuous sample space consists of some interval on the real line. So let's see the distinguish. So let's see first discrete sample space, and second one is continuous sample space. So first point, so consists of isolated values, and continuous sample space which consists of some interval on the real line, some intervals on real line. Second point is it may be finite or countably infinite. It may be finite or countably infinite. And here we know that interval is always what? Uncountable. So we say that second point is it is uncountably infinite. Third point is generally associated with discrete random variable. Generally it is associated with discrete random variable, discrete random variables. And in continuous sample space, generally it is associated with continuous random variable. Generally it is associated with with continuous random variable. Continuous random variable. For example, so let's see the example. If a dice is rolled, then, for example, if dice is rolled, so one dice is rolled, so how many sample spaces? So it has 1, 2, 3, 4 or 6 sample spaces, and in continuous sample space, so it is of the interval type. So I will write in, so rainfall of certain city, of a certain city per day can be, so sample space it can be written in the form omega is equal to x such that 0 less than equal to x less than equal to 1000 mm. So this is infinite, so uncountably infinite sample space, and this is countable, maybe countable or finite or countably infinite sample space. So this is the difference between discrete sample space and continuous sample space. Now let's see next point, which is events. So events, let's see the definition. Any subset E of sample space is known as event. Any subset E of a sample space is known as event. That is, an event is a set consisting of possible outcome of the experiment. That is, an event is a set consisting of possible outcomes of the experiment. If the outcome of the experiment is contained in E, then we say that the event has occurred. Means what? Because E is subset of sample space, right? So let's see the example. Following example will illustrate the concept of events. So let's see the example. First, if two coins are tossed simultaneously, then we will get E has sample spaces, means events which is subset of sample space. So which are the H, next HT and TH I have given, would be the event that at least one of the coins shows heads. Is the event, would be the event that at least one of the coins shows head. So there exists coin which is head, shows heads. So this is subset of sample space. We have sample space yes when to toss the two coins, which is HH, HT, TH and TT. So this is subset of this sample space. So this is an event. So second example, let's see. If two dice are rolled simultaneously, then so I have given event E, which is 1 4 2 3 3 2 4 1. So would be the event that sum of numbers on the uppermost faces is 1, is event that sum of number on the uppermost faces is 5. So these are the number whose sum is 5. So we have the sample space. If I roll 2 dice simultaneously, then we will get total 36 sample spaces. In that 36 sample spaces, we have taken only 4 sample spaces whose sum is 5. So this is subset of that sample space, and here is the event we have given. Now let's see some types of events. So which is elementary events, and second one is impossible event, and third one is sure event. So let's see that types in next lecture. Now we'll stop here. Thank you.